Now we've progressed to sort of the highest level of working with operational amplifiers, and that is to design circuits to perform certain tasks. So you can see that the problem statement here is quite simple. I simply want a circuit that will yield Vout equals negative 50 times Vn. And to me, when I'm looking at this, there are two things that I'm going to identify. First of all, I see the negative sign, so that tells me that this is probably going to be an inverting amplifier. And then I see that this number 50 is a reasonably small number, where I would define that as less than 1,000. So that means that it can be done in a single stage. So I'm going to go ahead and say, let's go ahead and do a single inverting amplifier. Let me go ahead and draw the inverting amplifier first so that I remember what it looks like. Now, you might say, hey, do you have what this circuit looks like memorized? And I would say, well, you know, when I'm in the midst of doing this sort of work, I do. But there are times when I have to go back and look at my notes to remember what the circuit looks like. So don't feel bad if you have to go back and look at your circuit. Certainly, these 4 building block circuits that we've studied would merit being on your equation sheet for the next exam. So I know that I have a feedback resistor, and I have an input resistor, and here's Vn. So that's what the circuit looks like. I know that that circuit will accomplish the task that I've been asked to do. The only thing I need to do is choose a value of Rf and a value of Rn. Now I know that the equation that corresponds to this is Vout equals negative Rf over Rn times Vn. And if I compare that to the required equation, I can see then that Rf over Rn is going to be equal to 50. The negative signs are already taken care of, so it's just 50. Now I can choose, I guess I can go ahead and multiply through, say Rf is equal to 50 times Rn. And you don't want the numbers to be smaller, the resistors to be smaller than about 100 or larger than about 100,000. Let me go ahead and just choose a value of Rn. So I'm going to say choose. Now choose means that I was not forced to pick this value. Another similar value would have been fine, but I'm going to go ahead and choose Rn is equal to 1 kiloohm. And then once I've chosen that value, now I have no choice that Rf must be 50 times 1 kiloohm, or 50 kiloohms. And both of those values are between 100 ohms and 100,000 ohms. So this seems like it's going to be a good design. So I can say this will be 50 kiloohms, and this will be 1 kiloohm, and the design is complete. So notice that really it comes down to look at the equation, figure out which circuit you're going to need, remember what the equation is, remember what the circuit diagram is, and then choose one resistor value, and then usually the rest of them are going to fall into place. So let's choose an op-amp circuit that will yield plus 100. So here I'm going to look at the plus sign. I'm going to say, non-inverting amplifier. And I see the 100. I say, okay, that's a reasonable number for one stage. So I can do this all in just one stage. So let's go ahead and draw the non-inverting amplifier. So I know that I'm going to have a thing that looks like this. Here's Vn, and then I'll call this R1, and I'll call this Rf. And I know that the equation for this is that Vout is equal to 1 plus Rf over R1 multiplied by Vn. So if I compare that to the equation that's required, I can see that 1 plus Rf over R1 is equal to 100. Rf over R1 is equal to 99, and therefore Rf is equal to 99 times R1. And that means that this is a pretty wide ratio, so I want to choose a pretty small value of R1. I'll go ahead and just choose, I'll choose R1, so I'll say choose R1 is equal to 500 ohms. And therefore Rf is going to be 99 times 500 works out to be 49.5 kiloohms. So this would be 500 ohms, and this would be 49.5 kiloohms. And that's the circuit that will yield 100 times Vn. And now we've got one where there are 3 voltages, and pretty clearly by looking at this, it's going to be the summing amplifier. We don't really have any other circuit that can do more than 1 input voltage. So let's go ahead and sketch the summing amplifier here. So I'm going to have the positive terminal is tied directly to ground. The negative terminal is going to have a feedback resistor. This will be V out. This will be RF. And then I've got 3 input branches, all of which sort of join up before the feedback resistor. We'll call this R1, and this will be R2, and this will be R3, and this will be V1, V2, and V3. And I know that V out is equal to minus, and you can either put the parentheses in or not. To make it as similar to this equation as possible, I'm not going to use parentheses here. Minus RF over R1 times V1, minus RF over R2 times V2, minus RF over R3 times V3. And so therefore I can see that RF over R1, I see that that's this expression right here. The negative signs are already taken care of, so that means that that must be equal to 3. And RF over R2, that must be equal to 2. And RF over R3, that must be equal to 4. I'll go ahead and choose RF to be 10 kiloohms. So again, I'm choosing that value. And then I can see that R1, if I rearrange this equation here a little bit, R1 is going to be RF divided by 3, which is going to be 10 kiloohms divided by 3, which is 3.33 kiloohms. R2 is RF divided by 2, which is 10 kiloohms divided by 2, which is 5 kiloohms. And R3 is RF divided by 4, which is 10 kiloohms divided by 4, which is 2.5 kiloohms. So I've got my 4 resistor values here. And if I were to label them back here on the circuit diagram, this one would be 10 kiloohms, and this one would be 3.33 kiloohms, and this one would be 5, sorry, this is going over the line there, and then this one would be 2.5 kiloohms. So that circuit diagram will yield negative 3V1 minus 2V2 minus 4V3. You just got to choose those 4 resistors. You say, maybe there aren't standard resistor values that are right on those values. In that case, you choose the resistor that's close enough or as close as possible. And if you need this equation to be more precise, you might need to use some series combinations of 2 or more resistors.